Dear learners, welcome to this massive open online course on operating systems. Today we are going to see about non-volatile memory scheduling and swap space management. So, we all know that in traditional systems we have the secondary memory which is called as hard disk drives, which has mechanical movement in terms of read and write head. For example, if you have a platter rotating on the spindle, and if they want to access any data, you have to move the read and write head mechanically to and fro. So, it takes a lot of time. In modern day systems, this latency will play a major role, and it affects the overall performance. So, now we are going to see about another variety of memory, which is called non-volatile memory. We all know that there are two categories of memory, one is volatile and non-volatile. So, volatile memory will erase the memory content when there is no power, whereas non-volatile memory will retain the content even the power is switched off. So, with this provision, we have systems which can provide non-volatile memory, which is using flash of flashing the content in the memory, where we can read or we can write dynamically. So, the topic which we are going to cover today is about introduction to this memory management as overall, and we have the overview of non-volatile memory, technologies involved, the characteristics of non-volatile memory, the role of OS in managing this NVM non-volatile memory, and the goals and objectives of NVM scheduling and swap space management, and how NVM is acting on behalf of swapping. So, there is no need for swapping in NVM, that is the ultimate objective, because swapping takes a lot of time to move here and there the data. So, memory is the critical system resource managed by the operating system. We all know that is the fundamental processing done by the operating system. So, many applications will demand a large memory capacity, the two with high speed of retrieval of data and persistence of data. So, you have to retain the data for a long time, even the power is switched on or switched off. So, the current applications demand all these criteria. So, the traditional memory systems will not handle all this, because we do not have larger memory capacity in the older systems, and there is no high speed mechanism to read and write data. And also the persistence of data is not that much, we have only limited persistent data memory. So, this traditional systems will not meet out these characteristics. So, we are going for a new technique called NVM non-volatile memory that introduces new possibilities, but also it has some few challenges because it is too costly to retain non-volatility for large size data. So, the main thing is in the non-volatile memory we have to introduce efficient scheduling and swapping mechanisms as essential for performance and reliability, but most of the cases in traditional systems we do swapping quite often, but in non-volatile memory issues we will not do swapping like what we do in the traditional memory systems. So, just for a recall, we can have the memory hierarchy. As we all know, it starts with the CPU registers, the fundamental smaller unit. Of course, we have flip flops. If we connected that in the serial, we call as registers, that is the fundamental memory unit. Then we go for cache memory, which is faster, and mainly it is hardwired. So, it is called static RAMs. So, it is very fast because of this static RAM connectivity. Of course, static RAMs are very costly, we cannot have static RAMs of larger sizes. So, there is a limitation for having static RAMs. Then we go for dynamic RAMs. So, here we have the main memory. So, the main memory size is little bit larger when compared to cache, but it loses the content as and when the power is switched off, it is highly volatile. Then we go for the level 3 memory, which is called magnetic disk, which has a larger memory capacity. So, the next level is optical disk, which is again having much more higher capacity. Then we can have a magnetic tape, which is having further more memory capacity. The pyramid shows that the top level we have less capacity, but accessing speed is high, whereas the bottom level 5 we have a huge capacity of memory, but accessing speed is very low. This is the hierarchy, memory hierarchy design, we all know this. So, why this hierarchical design we have to concentrate is to understand or to handle speed, cost and capacity. So, the capacity is more, the speed will be less, because we have to search for the data in the huge volume of data, and the cost also will vary depend on the type of memory which you deploy. For example, if you have a static RAM type, you have to spend more cost because of hardwired nature. So, this is how the levels are. The OS play a key role in managing all this in terms of allocating pages to the while processing in the CPU, then migrating data from higher one level to another level, because the memory capacity is different, and the currently needed memory needed data may be in one memory, whereas we have to shift that from this location to that location. Then we have to replace, for example, if I want to replace a item, then you have to choose which item you can choose for replacing. Okay. So, this is you have to find the victim data. So, that is also a decision making process. So, OS will play a key role on this page allocation, data migration, and replacement decisions. Again, if you want to look at the traditional memory systems limitations, we have the dynamic RAM, which is faster but volatile. There is not one non-volatile memory, and it is highly expensive. It is of limited scalability. You cannot increase just like that the dynamic RAM. If you increase, then addressing the locations in the memory will become an issue. Then we go for a disk based storage, where we have a persistent but very slow process. So, we can store the data for long time, but retrieving data from that persistent database or storage is very slow. High latency for paging. So, paging is one process where we have to find the respective page which we want to currently is CPU is seeking. So, if the page is there in the secondary memory, the disk based storage, then swapping from the disk based storage device to this current place where the page is required is will take a lot of time. So, it is high latency job. Gap between memory and storage is known as the memory wall. So, it is about how much time you take to store and retrieve data. So, it is the main thing which plays an important role in the performance of the overall system. So, we need for an intermediate memory technology which reduces this latency by instead of taking from the secondary storage, that is disk based storage, which takes a lot of time, we can put that in the intermediate level and then we can access. So, this is the objective. So, the solution for this handling this issue is non-volatile memory. This is a technology which works basically without any physical head movements. It uses flash memory concept, where it stores data and erases data at one instant of time. So, it provides data access in very quick time when compared to the previous method. So, basically what is non-volatile memory? Memory that retains data without power. So, even without power you can have the data in the memory. So, we can say it combines the property of dynamic RAM. So, dynamic RAM is RAM where we can access the location by using the byte addressing method. So, you can use that byte addressing concept, as well as we can use the disk storage type of persistence. Now we can store the data even there is no power. So, this is the combination of both the advantage. One is the dynamic RAM advantage, another is the disk storage advantage, where we can retain the data for a long time. One is we can address the data and we can access the data very fast. So, this is the combined property of both. This can be accessed via instructions by the CPU, like load and store for taking data and storing data. We can load and store instructions we can use. So, we can call this as an extension of memory, main memory, and it is a high speed storage. Swap replacement is possible. These are the main objective or the need for non-volatile memory, and this is extensively used in modern systems. So, there are different types and examples of non-volatile memory technologies. We have totally different concept of implementation. One is the phase change memory, which retains phase states, and second is resistive RAM, we call it as ReRAM. This holds the resistant states consistently to have a persistency of persistent for the data, and magnetoresistive RAM, it retains the magnetic states. So, 3D X point, this is one thing where Intel exclusively used for having a non-volatility in the memory management. So, mainly this non-volatile memory is used in high-end servers, databases and high performance computing scenarios. So, if you have advanced circuits that can do quick processing, we have to provide similar data storage mechanism also that can feed data as per the speed of processing. So, NVM is the one technology which we can use in the modern systems. Of course, this NVM needs OS level management policies to govern the scheduling part. So, the characteristics we can say it is persistent storage of data and lower latency than the SSDs which we had, slower than DRAM for writes. So, DRAM is much faster memory time, whereas this NVM is better overall, but when compared to writes it is slower than DRAM. Limited write endurance, that is one thing which NVM has to concentrate, and asymmetric read and write performance. So, here read is faster whereas write takes time. So, that is one issue because of its nature and property of changing the values in the memory location. These characters influence scheduling decisions. All these will have influence on how we can schedule the task, non-volatile memory. So, what is the role of an operating system in managing the non-volatile memory is the OS must decide which pages should go to the dynamic RAM and which pages should go to the non-volatile memory. So, DRAM has its own merit and NVM has its own merit. So, we have to identify which page we have to allocate for DRAM and which page we have to allocate for NVM. We have the various responsibilities as we all discussed. We have the page replacement, which page you have to replace for current execution, and page migration, from which memory location you have to migrate, and handling the faults. So, this NVM awareness has to be built into a module called memory manager. So, that module will take care of how NVM pages can be scheduled for NVM. So, why the scheduling is required? So, as like scheduling in generally in operating systems like CPU scheduling, disk scheduling, here also we have to concentrate on NVM scheduling. Uncontrolled writes reduce NVM lifespan. So, if you keep on writing more number of times in NVM, the lifetime of this electronic circuit itself will be affected. So, number of writes has to be optimal. We have to write whenever is very much essential. Random write patterns degrade performance, yes, because writing takes several times more time than reading in NVM. So, this random write will have a serious effect. Multiple processes compete for memory. Yes, since there are many processes involving in the operating system which need data from the memory, we have to schedule accordingly, thereby the correct process is accessing the data at the right time. So, this kind of regularization, that is scheduling, helps in reduce write traffic. So, keep on writing will affect the circuit itself, reduce write traffic, improve fairness. So, it avoids starvation, or it avoids giving priority for a particular process and neglecting the other process. Increase system throughput. Of course, if you have any systematic approach, you can have a better throughput. So, basic concept in NVM scheduling is determines order, priority and placement of memory operations. So, this will enhance the performance of the system, and of course, the throughput also will be based on this order and priority and placement of memory operation accordingly. So, the scheduling decisions consider three factors like read versus write request and access frequency and data criticality. So, these are the main decision parameters that you have to consider. What is the request arrives, for example, read is coming or write, or how frequent it is accessing the data, or the data how critical the data is to be accessed now. So, based on these three factors, NVM scheduling algorithms will allocate. The goal is to optimize use of hybrid memory. So, since the memory is of a combination of both dynamic RAM and persistence property, so we have to use the advantage of both. So, we have to be very careful in scheduling the tasks. Goal of NVM scheduling is to minimize write operation, because NVM is writing is not favorable for NVM because the circuitry will get affected. Extended memory lifetime, reduce application latency. Of course, our ultimate objective is to increase the speed of execution for the respective application which is running, improve overall system performance and maintain QoS, quality of service. So, we have the hybrid version, that is the hybrid DRAM NVM memory model, which has the DRAM cache for frequently accessed pages and NVM for store less frequently accessed pages. So, OS monitors all this and it assigns the page access frequency and write intensity, how many times you have to write in the NVM, because that is the main thing which you have to take care of NVM non-volatile memory handling. Page migrate dynamically between memory tiers. If you look at this, we have this NVM dual inline memory module and DRAM dual inline memory module. So, accordingly we have to assign the pages. So, we have a lot of pages here and the memory controller will control how pages are assigned. So, based on the core, for example, the CPU is running with multiple cores and the LLC is the last level cache that is handling the current data required for the core to be processed. So, we can access the pages either through this NVM or through DRAM. So, most frequently accessed pages will be via DRAM and less frequent pages will be via NVM. So, if you reduce number of writes and this hybrid DRAM will perform up to the expectation of the user. So, this is the structure of a hybrid memory controller which has the pages in the memory. We have bank 1, here we have another bank. So, this is purely for DRAM and this is for NVM. So, they have separate bus and using this bus we can access the pages. Next is swap spaces. So, for the currently if you want a particular data, if the data is not available, then you have to swap the data. So, there are a lot of schemes we have to adopt, how efficiently we can swap, how fast we can swap the data. So, we have swap space is a disk backed extension of RAM used when physical memory is insufficient. So, already we know that physical memory is always a limited resource, but the task which you submit for the system is huge. So, we have to use swapping mechanism for using the existing available physical memory. So, this swap space mechanism induces large virtual memory. So, virtual memory is nothing but a memory which is not physically exist, but overall usage of the memory will be several times more than the actual existing physical memory by using virtual memory concept. So, we use that that enables multitasking as well. So, managed using paging mechanism. So, how we do this task is to check whether the currently available data is useful. If not, we have to replace that data. So, that replacement is identified by a process, that process is called paging, that we will see. So, if you look at this, there are two processes, process P1 and process P2. We have P11, P12 and P21, P22 pages. These are the pages which to be replaced and we have to include. So, we have to put that in the secondary memory and we have to replace that with the current required pages from the secondary memory to the main memory P21 and P22. So, this is swapping in and swapping out. Since we are dealing the swapping process with the secondary memory takes a lot of time. So, this frequent swapping should be reduced in general. So, physical memory is as I said, the need for a swap space management is the physical memory is limited and shared by multiple processes. So, since many processes involved, the processes may be with different priority, schedule the process based on the priority of the process. So, that may access different data. So, always the required page may not be there in the physical memory. So, you have to swap pages. So, there is no alternative for that. So, that swapping has to be done effectively. So, we have this management, swap space management that handles that. Enables execution of programs larger than available RAM. So, as we all know that we can submit any task to a system. The system with higher RAM capacity will execute the task faster, with the system with lower capacity will task slower. But the reason behind is the physical memory limitation. So, number of pages available in the physical memory is limited. So, if the required page is not there, then you have to do swapping and swapping out. So, this process takes time. That is why lower memory, lower RAM memory systems will function slowly when compared to the larger RAM. Prevent system crashes due to memory exhaustion. So, if the memory is full, then instead of showing that the memory is exhausted, we can have a swapping, and we can still use the same memory. Freeze main memory by moving inactive pages to swap space. So, it moves the inactive pages well in advance, thereby the space is created for the available or required pages. Supports multi-programming and efficient CPU utilization. So, since multi-programming demands frequent access of different pages, this free space management, swap space management will play a major role in identifying the invalid pages for that particular moment and swapping that and replacing that with the required page. Helps maintain system stability and responsiveness. So, if you do this promptly, then the system will be stable and it will respond very quickly. Otherwise, the response time will be delayed. This may affect some real time applications. So, how it is organized? The swap space can be a dedicated partition or a swap file. So, we can assign a partition for swapping, or we can assign a separate file. So, the OS maintains swap maps. So, it is like a map which directly say that this page has to be swapped. We call it as page slot in the swap file. So, swap map will say it is 1 or 0. It will tell this is to be swapped and this is not to be swapped. So, we have a free slot list. So, the free slot list will be used for filling up the necessary pages. The performance depends on the contiguity and disk speed. So, how fast we are swapping will play a major role in the performance. So, swapping and paging is a process which happens when a current page is accessed. For example, when multiple processes involved in operating system, context switch will happen. So, during context switch, page faults will occur. So, during page fault, we have to identify the correct page to be recovered. For recovering this page, we may have to do swapping. So, this is how the page fault occurs when page is not in the memory, and OS selects a victim page. We have to select which page we can choose based on the paging replacement algorithms. That is a separate topic. The page which is not used for long time, the pages which you are using frequently, or whatever logic which you can apply, and you can identify this victim page, and we have to swap the page. Dirty pages returned to swap. Dirty pages are the pages which are not valid for the current execution. Required page loaded into the RAM. We have to load the required page into the RAM. Page tables are updated accordingly. So, if you load the new pages, correspondingly you have to update the page tables. So, this is the swapping and paging process which happens side by side. They both are running together. So, if you look at this diagram, you can have the operating system and user space where we can perform swapping in and swapping out from the backing store, that is secondary memory. This slide shows the full process of swapping and paging. So, it has the load, it is the instruction load m. So, load m, now you have to load the memory. So, the first step is it refers the page table. The page table says that for this reference the bit says that it is invalid. So, if it is invalid, then the page is not available, the required page is not available. So, it will generate an interrupt. So, we all know that trap is a non-maskable, generates an interrupt. This interrupt will be sent to the OS. What OS will do? OS will understand this interrupt is for page not available. So, it goes to the paging backing store, it finds the page, and this missing page will be filled in the free frame of the physical memory. So, 1, 2, 3, 4. Now, 4 the missing page is filled. Now, since the new page is filled in the free space, then you have to update the page table, that is the reset the page table. Then after resetting, now the current page is available. Now, again the load instruction will be executed. Now, instead of page fault, page success will be there, will be generated. So, there is no need for again doing this. Now, the execution will start. So, if there is no page in the page table, we have to perform lot of tasks. It is starting from finding the page in the page table, that is also a memory reference. Then we have the indication that invalid page. So, we are going for operating system generates interrupt. Of course, the operating system will give a priority for this trap interrupt handling. So, as soon as it handles this interrupt, it will go to the backing store, it will check the secondary memory. Searching in the secondary memory and retrieving the data from the secondary memory is the most time consuming process. So, every page reference will have a serious time consumption when there is no page available in the page table. So, then we have to assign that in the physical memory. So, this memory reference will be huge, it will take large time, whereas accessing the physical memory will take some time. So, we have to add all these delays to compute what is the page fault time when occurs for any page that is not available in the page table. So, that is the normal process in operating system. So, what are the policies we do? We have a lot of page replacement algorithms for swap space management. We have first in first out, least recently used, clock, make. So, we have so many algorithms over there. Then the swap decisions are depending on the reference bit, 30-bit and access history. So, these are the indicators which indicates when we have to perform swap. So, already we have seen some criteria, and this criteria will be indicated by these bits. So, objective of the operating system is to minimize the page fault. So, it has its own optimization of identifying what are the pages it has to swap. So, most frequently accessing pages should be retained, and least recently accessing page can be chosen as the victim. So, like that we can have a lot of logics for different algorithms in order to minimize the page fault. So, it takes a lot of time. So, what NVM as swap space? So, swapping is a time seeking process. So, this NVM non volatile memory can replace the disk swap, where the disk swap consumes a lot of time. So, we can have if you look at the structure, we have the CPU, main memory and the secondary storage, and since we are maintaining different level of caches, level 1 cache, level 2 cache, then we have to perform read or we have to perform write. So, all these decisions can be taken, and the secondary storage, if you implement using NVM, this NVM is a flash file system partition which will not do any mechanical movement of read and write head. So, it performs faster page in and faster page out. So, lower fault handling time. So, whenever there is any fault, page fault, its handling time is very low. So, it is much faster when compared to HDDs which we use in the traditional systems. The only thing is the OS must ensure that the write frequency in NVM is reduced to the maximum extent, because it affects the circuitry itself, and it handles persistence carefully, because the main property of NVM is to hold the data even the power is switched off. So, it is best ideal for high performance systems. So, as a summary, we can say that the non volatile memory bridges the gap between the main memory and the storage. So, we have a time consuming and large size storage, and we have the main memory which is faster. It bridges the gap between these two, and the scheduling improves the performance in the memory lifetime. So, if you have a proper scheduling, NVM scheduling, it increases the lifetime of the memory circuit as well as the performance. So, we have hybrid DRAM NVM systems that require intelligent operating systems policies that ensures that NVM pages can be used where there is number of pages accessing is not frequent, and DRAM where the pages are accessing is frequent. Swap space management is essential for virtual memory. So, virtual memory is the memory which is beyond the actual physical memory. So, by using this swap space management concept, we can implement the virtual memory as well. So, NVM based swap reduces the page fault latency, because it is flash type memory which do the back end secondary memory level swapping very faster. Effective memory management improves the overall performance of the system. That is all about this topic. Thank you for patient listening. Thank you.